You're going to write today's date, which is 8/22/22. Okay. Okay, today we're talking about using experimental probability to make predictions, okay? So you might not have a super fair event, like a coin flip or a number cube rolling. And so what people like to do is they like to make predictions just based on the data that's collected, okay? So experimental probability is the ratio of the number of desired outcomes to the total possible outcomes. Okay, so for instance, if I own a sandwich shop and on Monday 10 people ordered ham sandwiches out of 33 people that came in, then I'm looking at this. I'm saying, well, 10 ordered ham sandwiches out of 33 people that ordered sandwiches, and I can use that data to make predictions for the next day. So I might say, well, a little less than 1/3 of the people ordered ham sandwiches. And I can use that data to order enough supplies for the number of ham sandwiches that I think I'm going to be selling. Okay? So experimental probability is super important, and it's used a lot, okay, to help people make predictions about what's going to happen. Now our formula for this, just like our definition said, is the number of times an event occurs okay, and if you worked with me at all today, I refer to this as the parts, just in general, okay? So that would be how many, if we're using the example I just talked about, how many people ordered ham sandwiches, okay? So that happened, in this case, 10 times, all right? And then it's going to be out of the total number of trials, which in this case was the number of people that ordered sandwiches. And oftentimes I refer to this as the whole, okay, or the total. Okay, you have your total on the bottom, and you have your part, or what you're looking for, on the top. So let's use what we know about experimental data to answer this question. It says Sam has worn a green shirt 10 of the last 20 days. Okay, so using that part and whole ratio, what goes on the top? 10. Okay, so the probability of Sam wearing a green shirt is 10 out of how many total days? 20. Okay, that is the experimental probability, okay? Now, it's going to be important for us to reduce this fraction. So if I reduce 10 over 20, what do I get, Jocelyn? 5/10. If I reduce it even more, what do I get? Denise? 1/2. Okay, great. Good job, you guys. So this is 1/2. If we represented it as a decimal, that would be 0.5. If we represented it as a percent, it would be 50%. So based on what we know, Sam has worn this shirt 10 out of the last 20 days. We're going to assume or predict that Sam wears green shirts about half the time, okay? And if we want to use that data, how many times would we expect Sam to wear a green shirt in the next 12 days? So we're going to use that now, okay? Owen? 6 days. And how did you know that?
Because if it's just half, it's divided 12 by 2. I got 6.
Fabulous. Okay, do you remember setting up a ratio like this in 6th grade? Okay. Oh, you should have. You should have. Okay. So we're going to use the experimental probability 1/2, and we're going to set it equal to this, and we're going to have the number of times the number of trials, which is 12 on the bottom there, and then n is going to be the number of times he wears a green shirt. Okay. And using what Owen just said, was that your answer too, Jocelyn? Yeah. Yeah. You can actually, I'm going to show you with a different color, use your skills with ratios to scale it up. So we're going to multiply this by 6, which means we would also multiply the top by 6, and we would find that n 1 times 6 is equal to 6. Now, when you have a question in words, I want you to answer in words. So we're going to say, we would expect Sam to wear green 6 out of the 12 days. Okay? All right. So this is what I would call a graphic organizer. It helps us kind of organize our information. Okay? So let's answer another question and use this. So it says, of the pizzas recently sold at Pizza Pies, 10 had pepperoni and 2 did not. Considering this data, how many of the next 6 pizzas sold would you expect to have pepperoni? Okay, so how many pizzas had pepperoni? 10. Okay, so that's our part on the top is 10. How many pizzas were there all together? Lena? 12. So don't get lost here because it's not 10. You have to read the question carefully because that's pepperoni and then 2 did not. So altogether that is 12. And that was our whole. Okay. Now what we want to do is we want to reduce that fraction. So go ahead and reduce 10/12 into its simplest forms. Its simplest form. See the wheels turning. Ben, did you get it for us?
I think so.
What'd you get?
Is it? Is it 2, 6?
You want to phone a friend? Colby?
5, 6.
5, 6? Is
Oh.
that what you were going to say, Denise?
Yeah.
Everyone's good? Okay, let's talk about how we get 5, 6, 2. For those of us that aren't sure, you're basically, you can see that the top and the bottom are both divisible by 2. So I'm going to divide the top by 2 and divide the bottom by 2. And I get 5/6. Okay, if you're struggling with reducing fractions, that's okay. Mrs. Lakey and I are going to help you with it, okay? Now we're going to set up our ratio. We're going to take 5/6, and it says, how many of the next 6 pizzas would you expect to have pepperoni? Okay, so our total, our whole, is 6. So obviously, how many would you expect to be pepperoni? 5. That was a way easier problem than I think we all realized. Okay, so we would expect we would expect 5 pizzas with pepperoni. If you've never seen this abbreviation for with, it's just a W with a backslash. It makes note-taking faster. Okay? Once you are done with your notes, I want you to take out the yellow page that Mrs. Lakey gave you and slip it into your page protector, your whiteboard page protector. Okay, so let me show you what I mean by that. If I can find my whiteboard. Maybe. Okay, so here's my whiteboard. I'm just going to slip it in. And you guys, we're going to be doing this all year. You're going to have all kinds of these graphic organizers in your whiteboard. And then what I need you guys to do is make sure your Chromebooks are open to IXL because we're going to do, for the first time, we're going to do a thing called Group Jam. Okay, so I'm going to put up that up there so that we can use it.
Why are you recording?
Oh, because I posted on my